ProtoNet is another important algorithm in few-shot learning, and you will see that this is the second important algorithm in few-shot learning. So last time I explained matching net, which was for one-shot learning, but ProtoNet is a little bit more general, and not general, but in terms of accuracy, it has better accuracy. So in 2017, we have this article that, so there exists an embedding in which points cluster around a single prototype representation for each class. For example, in zero-shot learning, we just have one for each class. But for few-shot learning, we have lots of examples that the average of them is, for example, here is C3, the average is C2, and the average is C1. So prototypical networks learn a metric space in which classification can be performed by computing distances to a prototype representation of each class. And so we find the nearest class prototype. So in order to do this, we learn a nonlinear mapping of the input into an embedding space using neural networks and take a class prototype to be the mean of its support set in the embedding space. And classification is then performed for an embedded query point by simply finding the nearest class prototype. So we have some n-labeled example, x1, y1, xn, yn, and sk is just the set of example labeled with class k. So the objective is very simple. We just find the average. This is a kind of average, and we have an embedding function that we should learn that neural networks, which is represented by these parameters. After learning that, we have these, so each prototype, so this is the mean vector of the embedded support points belonging to a class K, for example. So now we assume that we have a distance. Your distance could be anything, and by that we can define distribution over classes. For example, what is the probability that we are in class K given your x? This is, for example, k could be any label. What is the probability that y is 3 given your query point? Your query point, by the way, could be image in natural language, could be text, sentence. In financial market, could be anything else. So in general, it works for many applications. So we just need, so this is just, you calculate the distance, and this is just a softmax of the distance. We look at it like a very simple classification, and so we minimize the negative like probability because we are maximizing this probability, and that's it. So we go, but what is important is that you first start with a number of example, n number of example, and k is the number of classes, and n of q is the number of query. So here is the time that you calculate that average that I told you. F is the embedding that I told you, and then denominator is number of classes, and after that we are ready to go to, so this is if you just take the log, you see that this is the numerator, this goes to the denominator, so take the log of the denominator, log of exponential cancel each other, so it remains this one, and then if you go through all queries, the sum of all of them is your objective that you want to minimize. So prototypical network, we can see it as a mixture density estimation, and we use the regular Bregman divergence, which is a very good divergence, and this is the definition of that the Bregman divergence, and you will see how that this is a mixture density. It's like mixture density estimation. And also you can reinterpret that as a linear model as well. So as I said in the previous lecture, the monoglot is easy. You see, state-of-the-art algorithm are more than 95, even 96%. But mini ImageNet is even hard. But because state-of-the-art is just 49%. So in this algorithm, ProtoNet, we have for 5 shots, we expect to have more accuracy than 1 shot because we have more examples. But even in 5 shot, still it is 68% accuracy. Remember, we are in 2023, and the state-of-the-art algorithm still have very low accuracy. And this is a very nice application of few-shot learning.